Welcome to lesson 7145, Pythagorean Identities. So let's take a look at our vocabulary. Okay, looking at some basic identities, most of these make sense. Maybe you don't remember number 4, so we have to go back to our Algebra 1 days and see that x squared minus 1 over x plus 1. How does that come to be? Well, x squared minus 1 is a special case when we did quadratics. It's x plus 1, x minus 1. This is called a difference of squares. I forgot. I'm sorry. That's x minus 1 in there. Over x plus 1. And so the x plus 1's cross out, and you're left with x minus 1. And that's how we get that. Here's some reciprocal identities: the cosecant and the sine, the secant and the cosecant, the cotangent and the tangent. Some quotient identities. We're going to be using all of these today. Square identities. So take a moment to think about these, and we're going to use these as well today. Okay, so find sine theta and cosine theta if the tangent theta equals 5 and the cosine is greater than 0. So the tangent of theta is equal to the sine divided by the cosine, or the sine times the secant, because remember the cosine times 1 over the cosine, which equals the sine of theta times the secant of theta. Okay, I'm just using some of the reciprocal identities. Okay, so now the tangent of theta equals 5, and using one of our square identities, 1 plus the tangent squared equals the secant squared, then 1 plus 5 squared equals the secant squared. So the secant squared equals 26. The secant is the square root of 26. And the secant is the cosine flipped upside down. So that means the cosine is equal to 1 over the square root of 26. Now notice I only took the primary root when I took the square root of both sides above. I took the primary root, the positive one, because it says the cosine is greater than 0. So that's our cosine. This is 1 over root 26. And then from above, from our original equation, sine theta over cosine theta equals 5. Then the sine theta equals 5 times the cosine of theta. If the cosine of theta is 1 over 26, then the sine of theta equals 5 over root 26. And here go our answers: the sine of theta and the cosine of theta using our identities. Okay, so when we're talking about this, we mean in a unit circle where y is the height, x is just the x, the horizontal, and r is the radius. This is where the r comes from. So we get all of these function identities. Okay, here goes some more identities. Thinking about the period and half of a period and things like this. Here's some even odd identities. Okay, so let's solve this problem. All right, if cosine theta equals 0.34, find the sine of theta minus pi over 2. All right, so we're going to use our first identity. We know that sine of negative x is equal to negative sine of x, or theta. I should have probably put a theta in here, but okay. So what I'm going to do is do sine -1 times theta minus pi over 2. And that's going to give me sine, when I distribute the negative, that's going to give me positive pi over 2 minus theta. And we know that the sine, now the negative doesn't go anywhere, it comes out front, because sine of negative x is negative sine x, so the negative comes out front. The negative switches the two things around, the angle and the pi over 2 around. And now we know that this part, sine of pi over 2 minus theta is equal to the cosine. So the negative stays the negative. We got the cosine of theta, and cosine theta equals 0.34. So negative, then the cosine of theta is equal negative 0.34. So theta could be 0.34 or negative 0.34, which gives us the same angle. So basically, if your angle is over here, then you had your reference angle. And we know that the cosine is the x value. And you get the same thing over here. So the cosine of positive theta is equal to the cosine of negative theta. Well, not the cosine of positive is equal. It's just the lengths. If the length is 0.34 or the ratio is 0.34, then negative 0.34 will give you the same angle when you do the inverse cosine.